So let's get back to the main topic at hand, which has been circle geometry. And I just want to give a little bit of a recap of the main ideas. So when we started talking about circles 6 lessons ago, what we realized is there's a lot going on inside a circle, and we haven't really thought about it that deeply before, up until now. And the main ideas that we dealt with were the facts that come with or deal with the center of the circle, and then the facts that also deal with something called a cyclic quadrilateral. And a cyclic quadrilateral is just a quadrilateral that has all 4 of its vertices on the circumference of a circle. So these were the, kind of 2 main areas that we've been talking about. But once you start to look deeper at circles, you get things like this. You get an arc, or you get a chord. And this chord can make an angle at the center of a circle, or it can make an angle at the circumference. And we spoke about the relationship between this angle over here and this angle up here. And there's quite a special relationship. We also spoke about, in the last lesson, we spoke about the exterior angle of the cyclic quad. And we also spoke about the interior opposites in a cyclic quad having a special relationship. Now, these are all facts that we need to learn about circles. And the fancy name for these facts are called theorems. And so whenever you use a fact or you use a theorem in an exam setting, we start to actually give a shorthand thing called a reason with it. And I haven't been focusing on reasons so far, but today I'm going to start to sneak them in a little bit. We're not going to focus on them too much, but they're going to start to be snuck in. And that whenever we use a fact, we supply the reason that we're using that names that fact. Okay, so that was one thing. And I think that gives you a feel for what we've been up to in the last while. Let me actually show you a list of the reasons. Now, I haven't spoken to you about all of these reasons yet, but I want to just outline them quickly. So the one I was talking about before is this one that the angle at the center and the angle at circumference. And so we have spoken about that one quite a lot in previous lessons. In the previous lesson, we spoke about the bow tie theorem, or what I called the kite, not the kite, I think we called it the bow tie. And we spoke about these pairs of matching angles in a circle. If we go back even further, we spoke about the angle in a semicircle. So that was quite an important one. And then the other things we spoke about in the previous lesson were the idea that opposite angles in a cyclic quad are supplementary. And we also spoke about the exterior angle being equal to the interior opposite. So give me a thumbs up if those ones that I've ticked all look familiar. I just want to check. Now, we haven't started using these fancy names yet, but I just want to see that you remember those, remember at least seeing those types of facts before. Just give me, I want to see thumbs down if you don't remember seeing them. Thumbs up if you feel like, okay, no, I've seen this. Just want to get a feel for that. Okay, good. Now, if we look at these, okay, Kamvaletu, hang in there. We're going to be doing questions today, and you'll see that this is going to come. We're going to bring the same thing back again and again. Also, I'm not going to use all the reasons today. I'm just going to start showing you them more often. Now, if you look at this fact, the first column says you're given something. The second column says the result. Like, what do you know? Like, what's the fact that you know? And then the reason that we use, or the shorthand. So for example, let's go back to one of the first theorems I spoke about, which is this one with that looks like an arrowhead. If you have the center of the circle, right? So you have to have this. If O is the center of a circle, there's O. Now, then the angle made at the center, which is this one over here, and the angle at the circumference using the same 2 points AB have a relationship. And that relationship is that the angle AOB, the angle at the center, is twice as big as the angle at the circumference. That's why there's a 2 in front of the small one. And the shorthand reason actually that I use, I shorten it even more. I just say angle at center equals twice angle at circumference. But again, we're not going to focus on reasons today. I'm just bringing that up broadly. So in a later lesson, I'm going to come back. Lesson 8 in the series is all about reasons. But just to get your brain thinking along these lines, I wanted to start by showing you today. But there's a little bit of a problem too. The problem is I haven't spoken to you about these first two over here. So I want to talk a little bit about these. And I also want to talk about this one over here called equal chords. So I'm going to start the lesson by just showing you a little experiment or a little example. So I think once we've done those three, we've covered two of the big sections in circle geometry. So let me go. Actually, let's look at the picture first. Let's have a good look. What do we have here? So you're given a center of the circle. You're given this AB. This AB is a chord. And then the line OC comes from the center of the circle. And it says you're given they're perpendicular. And in the second one, you've got a line coming from the center of the circle, and it's going to the midpoint of the chord. So that's what I want to point out, like what happens in those situations. And then in the other one that we haven't spoken about, where did I hide it? Oh, here we go. We have two chords that are equal in size, and then they make an angle at the circumference. And somehow they're equal, which I'll talk to you about now. But this is too much talking from me. I think it's time to show pretty pictures, guys. I think that is the key. So let us go look at a pretty picture, and hopefully that will help us understand this theorem a bit better, or this fact. Okay, first of all, who are the characters in the story? Well, I can make the circle bigger or smaller. That's not very exciting. Over here, we have a center of the circle, and the line is going to the midpoint. And what we notice is that as long as if we fix the line from the center to be perpendicular, it's always going to hit the midpoint of the chord. If you see if I go the whole way around, notice how at the moment the chord is split into two pieces, 7.02, and it's at a right angle. So we say this fact basically says if you've got, I'll actually draw it for you. If you've got a circle and you've got a chord and you have a line going from the center of a circle and it's perpendicular to that chord, then we know that that chord is being cut in half into two equal pieces. And this theorem is just line from center perpendicular to chord. And the reason this happens is it goes back to this thing called congruency, which I don't want to get into in detail, but basically these two triangles over here are going to be congruent or exactly the same. That's why this piece over here has to be equal. Now, the other fact that you need to bear in mind is that if I have a circle and I have the center and I have a chord, and if it goes to the midpoint, so there's a line here which says this is the middle. If that line is going to the middle, then we know that this line is at a right angle to the chord. And the quick way of saying that is just line from center to midpoint of chord. And that proves it's 90 degrees. Now, I suspect that I know that I'm being very abstract. We're going to go do a whole bunch of questions now about this, but I just want to make sure that you guys sort of get the idea of what I'm saying. If you sort of can follow along what I'm doing, give a thumbs up. If you're feeling like, whoa, you're going way too fast, give me a thumbs down, just so I get a feel for the group. All I'm trying to do is present you with a new idea. Yeah, okay.
Yeah, sorry, just also, I know of the GeoGebra that sirs use, it looks like two triangles, but just want to bear in mind with you guys as well, just to remember, it can come across as two triangles like that, or it can look like a T, like Sir's drawn at the bottom. So in other words, you don't see the hypotenuse of the triangle. So whenever you get something that looks like a T or something that looks like two triangles, it should be a big hint that we are looking at this theorem.
I love that. It's such a good way of thinking about it. Like the T shape is the giveaway for these theorems. Sometimes you have questions that look, oh, guys, I'm really drawing too many funny circles today. If you have something that looks like this and that, whenever you see these kind of T shapes, these facts are going to be involved. And it's just a line from the center to a chord, and it either goes to the midpoint or it goes perpendicular. So that's just basic ideas I want to expose you to. And then there's one more idea that I want to expose you to, and that is what happens if you have a chord over here and a chord over here, and you have the center of the circle, and both these chords are the same length. So these are what we call equal chords. And this is the equal chords theorem. Now, when you have equal chords, what is special? I'm going to draw this into a triangle now. What is special about the red line for that, the red lines for these two triangles I've just made? I want to see in the chat, what's special about the red lines when we think about a circle? What's the special word for what those red lines are called? And how might that be helpful? Imbali, yes. Dudu, you're on the money. Radii, yes. Cabello. So what we have is all of these sides are going to be equal to each other. So now what we have is, if we have equal chords and they're making an angle at the center, then the angle at the center, let me get a different color for dramatic effect. If these are making an angle at the center, these two angles are going to be the same because the two triangles are congruent by what we call side, side, side. They have the same bottom part, and they both have radii as their other two sides. So they have to be identical. So the equal chords theorem says, or the equal chords fact says, if I have two equal chords and they're making an angle at the center, then those angles will be the same as long as the chords were equal to start with. Now, following on in the same way, guys, and this is where maths gets so sneaky because it builds on itself. Think about if I did, okay, let me get a bit more space. And then I promise we're going to go to the questions. If I have a chord down here, and I make that angle here, and then I also have another chord up here. Sorry for the... Now, what happens? What about these angles up here? I know it's going to look like an absolute dog show. Forgive me for that. Let's zoom in so we can see my, looks like a confused symbol. What is the relationship going to be if we know that this angle and this angle are the same? What is going to be the relationship between this angle? I know I haven't drawn it to scale, but what should be the relationship between these two red angles? Can you see the arrowhead shape, guys? So it turns out that the red ones are going to be equal because if you look at this, that's the angle at the center, that's the angle at the circumference. So for example, if this was 60 and 60, then this over here would have to be 30 and 30. So just take a moment to think about that. The angle at the center is 60. Then you know the angle at the circumference is 30. Now, if you go across to the other triangle, you know that that is 60, and you know that because of angle at the center is twice the angle at the circumference, this must be 30. And so what you find now is that if you have equal chords, you not only have equal angles at the center, you also have equal angles at the circumference. Okay, now that was a lot of talking by me, and I think it's time that we go and practice this. Yes, okay, so the reason is equal chords subtends equal angles, yes. So we're going to do a whole lesson on reasons where we clarify reasons later. For now, I just want you to see the facts. That's all. Okay. Now, give me a thumbs up if you feel like you just let your brain digest the facts. Give me a thumbs down if you feel very confused. And be honest. I want to get a good feel for the group, how we're feeling. I'm just trying to show you some new facts about circles. If you keep those, again, be honest. Okay. Then, what we're going to do now, okay, Cole, we're going to come back. I promise we're going to come back to that stuff. So just hang on in there. Before we go to an old exam type question, I just want to show you what are the facts that we have in our brain to deal with so far. I'm going back to my very first page. So I love, what was, Miss Anya, what was it you said? It was like the T shapes. We have the T-shape facts. We have the arrowhead facts. We have the butterfly. Then we have sort of the semicircle, the equal chords, and the cyclic quads. Those are the collections of all the facts that we know about circles, and we're going to use them to solve an exam problem. Now, for now, I'm not going to stress about reasons. I may put some of the reasons in, but I'll put those in later. For now, I want everyone, I'm going to give you 5 minutes. So you've got from 1820 to 1825, and I want you to try and find the value of ACD. So where is ACD? What is that angle? And then I want you to find what is AED. And AED is, I think, going to be that angle. Okay, enough from me. I've spoken a lot. It's now time for you to start to remix all these facts. This is going to be tough, so don't be too hard on yourself. Take your time and just think through it gradually. And if there are any questions, please, I am free, so I'm happy to answer those questions. Things got real. Hey, Miss Anya?
Yeah, I think it was all fun when they're separate, but the moment you start joining them, it just looks terrible.
Yeah, it looks like a confused kite that got tangled in a, so what you do is you
yeah, you're actually quite right.
Yeah. It's like a kite that got stuck in a hula hoop or something.
And then guys, sorry, excuse my dogs, a golden trick also, or golden tip as or whenever you do geometry is use color, lots of color. And also, if you work out one angle, write that value in your image. I know you guys don't have a hard copy of this, but write it down because you might need to use that value for something else.
Yeah, I think the color tip is such a good one. So when you think of these theorems, you're going to think of different types of shapes that you know, like the arrowhead one. Now, when you see that shape, trace it out if you need to. You can see here that there's an arc or actually there's a chord. You can use either, and we can make an angle at the center, and we can make an angle at the circumference. We say that the chord AD subtends an angle at the center and it subtends an angle at the circumference. Now, when you see that theorem, you should remember that, oh, the angle at the center is double the size of the one at the circumference. So I'm just going to give you that 50. I hope that helps a bit, David. And if we were writing in reasons, we would say angle at center is twice angle at circumference. That would be 2 marks. So 1 mark for that, 1 mark for. But yeah, we're not worrying too much about that. How do we get up to this thing at the top here? These little whiskers here do tell us something quite helpful. Maybe that could be helpful. Or what other shapes can I see that might help me? Is there a bow tie hiding there maybe? What do we know for sure? Oh, and what about this? What about, do we know what that angle is? That might be helpful. So this is a little bit sneaky. I'm going to give you a hint for this. Imagine instead of using the arc, okay, let me change my color. Imagine that you had this whole long arc around here. And this arc was making an angle at the center that was that one. And then imagine that that same arc was making an angle at the circumference, which is that one over there. Don't you know the relationship? Now, the problem is the 100 is actually not the angle in relationship. And this is what can be a bit tricky. It's this one on this side has a relationship with that one over there. It's like the diamond shape. It's no longer the arrowhead shape. It's the diamond shape. If only there was a way that we'd learned about in grade 9 geometry that could help us get what that is. That's my hint for the second one.
And then, so can I also jump in here?
Yeah, because this is getting real.
I'm also just going to hint but for the second one, there's also another route you could have gone.
Okay.
And all I'm going to say is look at AEDC. And tell me what shape is AEDC. So we'll highlight it as well.
Oh, I see what you mean. And actually, this is like isn't that a cyclic quad? Oh, yes, you would. Oh, you're
and we
right.
have C's value. We have C's value. C's value is 50.
Yes. Oh,
so
flip.
Well.
Yes. Oh, guys, I'm making it more difficult than it needs to be because aren't these opposite angles in a cyclic quad? Now, that's going to mean this is 1. I gave it away, sorry. But that's going to make this one 130. Because you can see all 4 of these sides on the outside of the circle. So that's how we got that. And the reason, if we were putting it, would just be opposite angles, cyclic quad. That's the shorthand. I know I'm writing. Yeah. Okay. So, well, that was much easier, Miss Anya. I like your way better. My way was to get this one, which was 260, and then to say what's half of 260, because it's angle at the circumference, or angle at the center, and then angle at the circumference. Luckily, we get the same answer. So
yeah, but that's also kind of why I like geometry, because not everyone sees these things the same. So obviously, you know, we come with a lot of practice, but some of these learners, they might not have been able to see what I see. So I think that's also what's quite nice about geometry. As long as you get to the same answer, that's all that matters.
Okay, where are we going next? It's EDA. So EDA is that red dot over there, and ABE is this angle over here. And we're going to give you some more time because these are proper exam questions. This was taken from old exams. So we've now reached a pretty decent level. Okay. And Zayanda, what reason, could you give me the reason in the chat? How do you know it's 25? So Zayanda said 25. what would the reason be that you would use, just so we start to get used to these? Or does anybody else want to tell me in the chat, what is the reason? Or you can jump on. What reason are we using? Sum of angles in a triangle. Yes, a triangle adds up to 180. And this is an isosceles triangle. So these two have to both be 25, essentially. They have to be equal. You equal chords. Let's look at equal chords. You could, oh yeah, that's sneaky. Let me, there's too much going on in my drawing. I need to get rid of some stuff. So that chord makes that angle. We can't use equal chords in this question. There are equal chords. A, E, and ED are equal, but they're not making angles on both sides. So I don't think you can use that, but I definitely see a bow tie. So let me just put what I know. This is 130. This is 25. What is angle ABE going to be? Okay. So ABE, it's going to be 25 as well. And that's going to be because the reason would be angles in same segment. And again, we'll go back to reasons another time. For now, I'm most interested in the 25. How did I get D's answer? Basically, I went, if this is 130, then these two have to be equal. And they're a triangle, so they add up to 180. So 180 minus 1, so 180 minus 130 is 50. And that 50 has to be shared equally, which gives me 25. Okay, just a general, again, I know this is getting harder. General feeling on the floor. Thumbs up if you're feeling good, or you're feeling kind of moderately good. Thumbs down if you're feeling very lost, just so we have a feel for you guys. Okay, it's good. Okay, guys, it's time for our brain break. So, you know how it is, your brain gets tired. I want you all to stand up, and we're going to do the midnight.
So I've got one.
Oh, have you got one? Oh, please.
Please.
Share your screen. Take over the, I'll stop sharing for a second. And then you can be the focus. And then I love a new one, please. And I can look silly too.
Just excuse my inja, guys. He's being a bit of a baby tonight. So this is my little inja. Right. So I also struggled this one. Okay. So you've got your fingers like this. Okay.
Oh my God.
But what do you do to get them straight?
Okay. Oh, wow.
So you need to think carefully. You go from this and you go like that. Okay, but obviously without like removing. So what must you do?
So what? Say it again. So you go like this, and now I have to.
Okay. So like now I can't do it because my fingers are crossing. Okay.
Yeah.
Right. So I need to go like this, and I need to straighten without letting go of my nose.
Okay. So the important bit is you can't let go of your nose.
Correct.
Okay.
So you must think carefully. So and you can't move. Can't move. Okay. So if you put your fingers like this and you try to pull back, they're going to keep crossing and your nostrils are going to close. Okay. So there's a little trick, but I can't try to show it too much, but that's something to play around. So if it's this, you can't cross. So there's something else you're going to need to do. Okay. Now I'm also I'm getting confused with my own hands now. Wait, I had it now. There we go. Okay. Can't cross. Okay. And I think like this. There you go. I got it right now. So I first want to see that everyone try, and then I'll show you what to do. Even my dog's getting curious. So if you do that, can't cross. Okay. If you do, oh goodness, can't cross. Even I get confused with my own tricks.
Yeah.
No. I had it so well now.
No, it's fine. Don't worry. The main purpose of the brain breaks is just to give us a chance for our brains to kind of escape for a second. And then the other thing I want students to quickly try and do is I want you to try and do this. And again, a shout out for the person who can do this question. Can you solve it? And put your answer in the chat, and then we will return to the maths. But we just needed a quick break.
Yeah. So while they're figuring that out, I'm just going to show you the tip. start with this. So one finger on each nostril, and this is how you work it out. And then you go back. So that's how you get. So yeah, I also get confused, but that's how you do that. So if you want to show your friends at school cool trick, you can do that. All right, so back to you.
Cool. Yeah, keep them coming. In fact, maybe if students in future lessons have brain break tricks that they know about, then I will give you the floor and we'll let you show us your one. So please think about that, because I have a couple, but I love learning new ones. Okay, let's see in the chat. 1 is the answer. Let me see if I can work this out. So according to BODMAS, I should be doing these ones first. So that one's going to get 9. And then I'm going to divide that by 3. So that's hanging around, plus 9 divided by 3. So plus 3 minus 3 over 3 cubed. And that's 3 over 3. And then that's going to be 1 because it's just 1 cubed. Yeah, so that question actually, as long as you understand BODMAS properly, you're good to go. Okay, let us do another, let's see, a formal question. Let's have a look. Did that one. Okay, now let's do one of the earlier ones. So I want you to try and do this question for me. So you're given a circle with center O and a chord with AB is equal to 16 centimeters. D is the midpoint of AB, AO is 10 centimeters. Determine the length of OD. So you have to work out what the length of this one is. And I want you to try and do that using the facts that we've spoken about today. I'll leave it to you. You've got about 2 minutes or so to do that one. You may need to use some other knowledge from geometry. Yes. David, I think you're onto something. I think you're onto something. So David's asked, can he use Pythagoras? Well, normally we only have Pythagoras when we have a right angle, but David, because this line from the center is coming to the midpoint, we know that this is a right angle. Now, I'll wait a little bit more time before I give the answer away, but Simone, Zakira, I think it's looking good. I just need to work it out still, but yeah. And so line from center, this is actually line from center to midpoint because it's going to the midpoint and that proves that it's perpendicular. Okay, first of all, we know that these are equal each. So this is going to be 8 and that's going to be 8. We know it's a right angle because there's a line from the center. So a line from center to midpoint of chord. But that doesn't solve the problem because what we're after is this guy over here. So using Pythagoras' theorem, 10 squared equals 8 squared plus, should we call it OD squared? You don't have to call it OD, you can call it X if you want. So using that knowledge, 100 equals 64 plus OD squared, which means if I take away 64 from both sides, 36 equals OD squared. If I square root both sides to get rid of this root, answer should be 6, which I see that it is, which is great. Okay, let's do another question. You have to use your knowledge again. I'm actually not going to say anything. All I'm going to say is you are trying to find out what the length of OP is. Over to you guys. Yo, Judu, you're on fire. I haven't checked if your answer's right yet, so I don't know. but those answers are coming in chop chop. What does it say here? O is the center of the circle. So I've got the center of the circle. SP, what's special about SP? SP goes through the center, so it's a special type of circle. OT is perpendicular to QP, and OT is 40. Now, if they happen there, if that is what we know is this bit over here is 40. Now, we know there's a line from the center perpendicular to the chord. So do we know anything about this bit? Well, the theorem says if you've got a line from the center perpendicular to the chord, what does it do? It cuts it exactly in half. So that should help us get the red bit. How do we get the length of, calculate the length of QP? Oh, wait, where is, well, QP is not that hard. Yeah. So let's actually work out OP as well, because I think in the question I kind of confused people. So calculate the length of QP. QP is just this bit. But OP, could we work out OP? Let's see. Maybe I've missed something. So OT is 40. So what you know is because of that theorem, this is 40 as well, which means QP is just 80. Now, what I'm curious about, I suppose I shouldn't have rubbed that out, is could we find what OP is? Do we have enough information? We know that SP is 100 millimeters. Who can get OP? I want to see if, yeah. So let me actually do this with you because we're running out of time. If SP is the diameter and it's 100, then OP must be 50 because it's half of the diameter. Yeah. Oh, well done, guys. We are winning. Okay, let us go to another exam type question. So let's see if we can get, not this one. So again, I'm starting to kind of expose you to these rather complicated looking drawings. But again, I want you to just slow down at the beginning. And what I did with my students is I always read through the information slowly first. And then I'm going to let you do these questions. So in the diagram, O is the center of the circle. You can see there is over there. PWSR, let's see if I can. PWSR is a cyclic quadrilateral, which is useful. PS, W, and OS are drawn, but in addition to that, we also know that angle P1 is 36, and we also know there's parallel lines PW parallel to OS. Now, parallel lines have their own relationships that we need to think about. So I'm going to give you, again, five or so minutes to try and do as best you can. I will start doing these as we go. I'm not going to leave you alone for the full 5 minutes, but I'd like those of you who can to try and get these 4 questions. And there's more than one way to do it. So see what you can do. Where would you start? I'd start by knowing where is SOW. Where is SOW? Ah, okay. So this is what I want to find. The only thing that I have in the whole drawing is this P1 up here. And so I'm going to have to somehow find a way to connect it. How could I connect it? I'll give you a little bit more time, but Leffe Cornolo, I think you're on the money there.
Sir?
Yes.
Can I ask you just to zoom in a little bit so that it's only the 4 questions, the info, and then the circle? Is it possible?
Okay, that's about as good as it can get. Is that good?
That's fine. Thank you.
Okay, now I can see what's going to happen in this question. This is just to keep things sneaky. I'm going to help you by just drawing some pretty colors. See if that helps you. Keep those answers coming in. Oh, I see my camera's a bit out of. It's quite hard to have your camera pointing in the right place. There we go. So what theorem is going to be involved in the first one? This is actually angles in the same segment. Oh, it's not angles in the same segment. I lie. Oh, I almost got caught. Look here. This is an angle at the center. And this one is an angle at the circumference. The 4 points are not cyclic quadrilaterals because the point in the middle is the center of a circle. Normally when we have the butterfly shape, or not the butterfly, what do we call it? The bow tie. We have all 4 points on the edge of the circle. That doesn't happen here. So the theorem actually SOW, and I think this will catch a lot of people, is 72 degrees because it's double the angle at the center. Or if I put the reason, angle at center is twice angle at circumference. So that it almost caught me. So I'm sure it caught some people. 72 degrees for that one. So what about W2? Where's W2 hiding? Well, what's the connection between W2 and other angles that we have?
Sir?
Yeah.
I don't know if the learners can see it, but if you look carefully, there is a set of parallel lines, which takes us back to grade 8 and 9. That's all that I'm saying.
So I'm going to point this out because I think it is very unclear. There's these little arrows, and what that's saying is that this line is parallel to this. Now, I think some of you may have heard of the Z shape and use, there we go, Kitty Bonner, alternate angles. Aren't these in a relationship where that 72 and that alternate angles are equal? And so we would say, and it's not the only way, but we'd say alternate angles equal PW parallel to OS. So we're saying these are the parallel lines. We can actually just say alternate angles. We don't even have to say alternate angles equal. Alternate angles PW parallel to OS. So this one up here is going to be 72 as well. Who can do OSW? Where is OSW? OSW is this big angle up here. It's made up of S1 and S2. So OSW is S1 and S2. What relationships can we use? Oh, what about S2 being related to something? Let's see what we can do. So Ayabonga Jolumba says S1 and S2 are 18. Well, let's have a look. I think that there's another Z shape here. So I think that this is parallel. And so I think that the relationship between P1 and S2 is going to be 36 because of alternate angles being equal. But now I need to know not just the S2, I need what S1 is. How can we get S1? Any ideas? Let's have a look. There might be other ways of doing this. There are also, the other thing is that you do get cyclic quads involved here. But there's actually multiple ways we could do this. Let's have a look. So that's 72. Oh, there's radii as well. Oh, there we go. That's probably easier. There's so much information on this drawing, but can you see that isn't this from the center of the circle? And isn't this also from the center of the circle? What does that make what does it make this triangle? It's a isosceles triangle. And you know that the middle is 72. So what is S1 and S2 going to be together? Well, you can see that if this is 72, being a bit tricky. So 180 minus 72 is what? It is going to be 108. So that's what's left for these two to share, because these are equal radii. So I've used up 72. What's left? 108. I divide it by 2. And what I get is 54, which means OSW is going to be 54 degrees. That was tricky. That was tricky. But I hope that after seeing it, all of you guys can, maybe you wouldn't have got it, but you can understand the logic. It's that these radii were hiding. They were hiding their secrets from us. And there was so much going on in the drawing. Okay, we've got a little bit more time. Now, the last one we need to try and get to is R. But while you guys are doing that, I'd love to take some questions. So does anybody have maybe I can help you clarify something. Susanna, go ahead. What question do you have?
Excuse me, sir. I'm just wondering. So why wasn't O 36 because of the same tangent, angles on the same tangent? Segment,
because, okay, this is really important. My brain was drawn to these 4 points, but look at how only 3 of them are on the circumference. If you want angles in the same segment, you need to have all 4 points on the circumference of the circle. That's a really important idea.
I think I'm actually happy she brought up that question, because I also saw that in the chat. So if you see a bow tie, okay, that's good. But then ask yourself, right, are all points of the bow tie, are all points of the bow tie on the circumference? If not, and they're like this one, one of them is at the center, then that one will be double the 36 in this case.
And it's like hiding away, because the reason it works is nobody focuses on this chord at the top. Now, if you look at that chord, that subtends an angle at the center, and then it's also subtends an angle at the circumference. Now, the problem is this looks to us like a butterfly, but it's not the butterfly that we're used to, because normally the angles are made, actually, I don't want to go into too much detail, but normally both angles are at the circumference. The problem here is the one's at the circumference, the one is at the center. Really. Okay, what do we have left? Let me put this back. So that was 72, and then that was 54, and that was 54. What's left? R. Where is R? R is hanging on down here. So how do we get R? I feel like a cyclic quad. Oh, we worked out W2 at 72. So we know that this angle over here and this angle over here are opposite angles in a cyclic quad, which means they add up to 180. Kiribono, I think you're with us there. Let's just make sure we know what that means. So we've got 180, and I'm taking away 72. The reason I'm taking away 72 is because of this 72 over here. And then there's a 54 next to that. So I'm going to take away that 54. And then see, what do I have left? So I have, if I take away 126, I should have 54 left, which means that this one over here must be 54 in order to add up to 180. And so the answer for R is going to be 54 degrees. Yes, go ahead, Dudu. What do you have on your Is your question?
Sorry if I'm going like a bit back, but
No, it's fine.
for 7.1, I understand why we can't use like the bow tie
Yeah.
method, but I'm still a bit confused on how we got the 72.
Okay. It goes back to the theorem, which says if you have, it's just facing the other way around. So if you think about a chord and then you think about a circle like this chord AB is going to subtend an angle at the center, and you're going to get that angle. And there's a theorem that says the angle at the center will always be twice as big as the angle subtended at the circumference. So this angle over here is going to be half the size of this angle over here. But they both have the same base AB that is basing or subtending the angle that we're forming. Now that's an important relationship that we covered in lesson, I think lesson 2 in a bit more detail. But that is the thing there. Okay, now guys, what I'm going to do is the lesson is almost done, and I'm going to let you go off to do that quiz. But I just want to mention in the quiz tonight, I thought we might be on tangents already. And so there are 3 questions on tangents. I just want you to do as best you can. We have not spoken about tangents in circles yet, but I'll give you a quick little reminder. A tangent is a line that touches a circle in one place, but and one place only. And so next week, we're going to do some lessons about what happens when we have a tangent connected to the center of a circle, and what happens when we have a tangent, or what happens when we have a tangent and it makes an angle with the circle. But I just don't want you to feel too stressed. When you see those questions, I put them in a long time ago. And so for tonight, you can just guess those questions.
But
Okay.
Sir,
Yes.
I posted the link in the chat now, but also as you drew that, all that I'm going to say is think of T. Think of T. That's all I'm going to say. That will help you.
Yeah. And it's been really nice teaching you. I know today's lesson has been much harder than any other lesson we've done. And so if it is your first lesson, you have good reason to feel a little bit confused. There were 5 or 6 lessons building up to this. And even if for the students who were here for all those lessons, they would have found today a bit difficult. Today, it's almost like I went from sort of moderate training to high intensity training. And so you need to give yourself some time to adapt and adjust. Anything more from you, Anya, before we answer any questions for students who want to ask questions?
No, I'm quite fine. Just again, I posted the link in the chat. Once you're on it, just press start quiz, and when you're on, you're welcome to hop off. If you have any questions, you can stay on and ask either myself or Sir.
Okay. Yeah, so if you're feeling comfortable and you're ready to go and do the quiz, and then I'm going to say good night to you. Thank you for coming today. It's been a lot of fun. It's lovely that the group is growing each time that we do this.